A system of linear equations is a set of equations for lines that we look at the same time. One way to find a solution to a system of linear equations is to graph the two lines. If we can find a point that the two lines have in common, the x and y coordinates of that point are the solution to the system of equations. Now for this system, the point 4, 1 is a point that both lines have in common. So the solution to the system is x equals 4 and y equals 1. To confirm that we found the solution, we can substitute 4 for x and 1 for y in both equations, and sure enough, those numbers make both equations true. Sometimes we get some surprising results when we try to find the solution to a system of linear equations. Let's look at this system to see what happens. We'll go ahead and graph both lines and see where the two lines cross. For the first line, let's just pick out some numbers for x and substitute them in the equation to see what the corresponding y values are. So when x is 0, y is 2. Now let's find out what happens when x is 1. When x is 1, y is 4. And finally, let's see what happens when x is 2. When x is 2, y is 6. We've used a table of values to find 3 ordered pairs on the first line to graph it. Let's try a different method for the second line, since it's written in slope-intercept form. We can see that the slope of this line is 2 and the y-intercept is 2. So we can start by graphing the y-intercept at 0, 2, and then, thinking of the slope as 2 over 1, from that point we can go up 2 and to the right 1, and we find a second point on the line. And now all we have to do is draw the line that connects those points. Can you see that the lines are right on top of each other? That means the lines coincide. So what's the solution? What points do they have in common? Well, any point that's on one line is also on the other line. And since a line consists of an infinite number of points, the solution is infinite solutions. All ordered pairs that make the first equation true will also make the second equation true, and that's an infinite number of points that they share. We could also describe this system of equations as a dependent system. A dependent system of equations have infinite solutions because the lines coincide. Now let's look at 2 other methods for solving this same system, and these are methods that don't involve graphing. The first one is solving by elimination. To solve by elimination, we'd like to add the left sides of the equations and the right sides of the equations together to eliminate a variable. So maybe we'd like to eliminate the y variable. Well, in order to do that, we'll have to rewrite the second equation so that the x and y terms are on the same side of the equation. And then, when we add the 2 equations together on the left side, we can see that the y variables are opposites, so they will be eliminated. But the x variables are also opposites, so they'll be eliminated. And since opposites add to give us 0, when we add the 2 equations together, add the left sides and add the right sides, we get the statement 0 equals 0. 0 equals 0 is a true statement. And when we see that we have a true statement, all of our variables are eliminated, and we simply have a number statement that's always true, we know that the lines coincide. We have a dependent system. And our solution? Well, that's infinite solutions. There are an infinite number of points that the 2 lines share. Now let's try one more method for solving the same system of equations. This is solving by substitution. To solve this system by substitution, we're going to notice that the second equation is already solved for y. So it's going to give us a way to substitute for the y in the first equation. Y gets replaced with 2x plus 2, and now we simply need to combine the like terms on the left side. So 2x minus 2x minus 2, 2x minus 2x is 0, and 0 minus 2 is negative 2. So we get the statement negative 2 equals negative 2. It's an equation without any variables that's simply a number statement that's true. -2 does equal -2. That means that we have a dependent system, our lines coincide, and our solution? That's right, our solution is infinite solutions.